Hey everyone, this is MJ and I am here to teach you Supermesh analysis for you to be able to solve tricky circuit problems. Hi guys, today we will be solving this circuit problem. Employing the Supermesh technique to best advantage, obtain numerical values for each of the mesh currents identified in the circuit depicted in figure 4.71. Now, the circuit already shows three loops. We have loop I1, loop I2, and loop I3. Now here, this rectangle here is a mesh, this here is a mesh, and this here is a mesh. Now this means that I1 loops around this mesh, same with I2 and with I3. Now as you can see, we have here another mesh which we can name loop I4. Okay, here now we have I4, and now what makes this mesh different is that it has a current source here. Now this means that we already have a value for I4, since this current source, this current already loops around this mesh. So here we can write I4 is equals to 3 amperes. So now we already have a value for this mesh. Now what we're going to be looking for is the value for I1, I2, and lastly I3. Now since we have three unknowns, we also need three equations. Now we know that we have three meshes right here. Now you can use Supermesh when there is a common current source between meshes, and here we can see that there is a common source between I1 and I2, which is this 1 amp current source, and we have another current source here between I1 and I3, which is this negative 2 amperes. This means that we can use Supermesh. So instead of having three meshes, we can have a single Supermesh. So now our Supermesh is gonna look like this. Okay, you can follow along, right, like this. Okay, and we will have a loop, okay, starting from here. They'll go around to here and then go back from the start. So now that will be our loop for our Supermesh. Now using our Supermesh, we can find an equation. So here, so to find the equation at the Supermesh, we will be using KVL, or the Kirchhoff's voltage law. Now Kirchhoff's voltage law states that the sum of the voltage of the branches is equals to 0. So that's what we're going to be using to find an equation. So KVL at Supermesh, which KVL states that the voltage of the branches is equals to 0. Now this actually has multiple branches. Let's just say that we connected them all, and we're going to use that to find the equation. So here again, we're going to be starting from here. So following our loop, we're gonna stop here. So here we have a voltage source, and as you can see, we go in the positive side of the voltage source, which means our 8 volts is positive. Then as we continue here, again we see a voltage source again. So here we go in the negative part of the voltage source, meaning our 2 volts is negative. So here we write -2. Then as we continue here, we have a 2 ohm resistor. Now to find the voltage of the 2 ohm resistor, we will be using Ohm's law. Now Ohm's law states that the voltage is equals to the current times the resistance. Now we can see here we have a value of two resistance on this resistor, and we have a current of I3. Now to get the voltage, we multiply them two, then we get plus 2 times I3, which we have is 2I3. Now as we continue here, we again see a voltage source. We go in the negative, meaning our 3 volts is negative, so here we write minus 3. And then as we continue here we see a 3 ohm resistor. Now again, so using Ohm's law, we will multiply 3, but as you can see, we have 2 current here. So here we can put a sign here, so here this side is positive while here is negative. Now as you can see that I2 goes in the resistor in the positive side, while I4 goes in the resistor at the negative side. So this means that I2 is positive and I4 is negative, meaning we multiply 3 ohms. So we multiply 3 ohms with I2 minus I4, and we already know the value of I4, which is 3 amperes. So here we have multiplied by I2 minus 3 here again. So as we continue, here we see a 5 ohm resistor. So here we have a positive, negative. So again, I1 goes in the positive side of the 5 ohm resistor, and our I4 goes in the negative side of the resistor. So here we have 5 multiplied by I1 minus I4, which is 3, is equals to 0. So now that we have our equation here, we can simplify this by using algebra. So here we have 8 minus 2 minus 3, which is equals to 3, plus 2I3. Then here we have plus 3 times I2, which is 3I2. Then here we have 3 times negative 3, which is negative 9. Then again we have here plus 5 times I1, which is 5I1. Then 5 times negative 3, which is negative 15, which is equals to 0. Then for further simplification, we can write I1 first. So here 5I1 plus 3I2, and then plus 2I3. And then we can move the constants to the right. So here we have negative 3, or negative 9 becomes positive, negative 15 becomes positive 15. Now for the simplification, we have 5I1 plus 3I2, okay, this was wrong, 3I2 plus 2I3, which then equals to 21. So now we can name this here equation 1. So now we have our equation 1. Now, since we have 3 unknowns, we need 3 equations. Now we have 1 equation. So, to find the remaining 2 equations, we will be looking at these 2 current sources since we are using Supermesh. Now, as you can see here, I1 goes against the direction of the 1 ampere current source, and I2 goes with the direction of the current source. Now, we can write this equation here as I1, so negative I1 plus I2 is equals to 1 ampere. So here we have negative I1 plus I2 is equals to 1. Okay, so here we have this is actually the equation, or equations actually, equations in the Supermesh. So in the Supermesh, so we can name this as equation 2. And then our last equation here, so as you can see, we have a negative 2 ampere current source. So again, our I1 goes with the direction of the current source, meaning it is positive, and our I3 goes against the direction of the current source, meaning it is negative. So here we can write positive I1 minus I3 is equals to negative 2. So here we have our equation 3. Okay, so we can write this. So we have our equation 1 here, 5I1 plus 3I2 plus 2I3 is equals to 21. Negative I1 plus I2 is equals to 1, and then I1 minus I3 is equals to negative 2. So these are our three equations so that we can solve for I1, I2, and I3. Now we will be using a matrix calculator to solve the values of I1 and I2 and I3. So here we have a online Cramer's rule calculator to solve our equations. So here we set it to 3, and then we input the equations we got from earlier. So here we have 5, 3, 2, and then 21. Then we have negative 1, positive 1, 0, and then 1. Then our third equation, we have 1, negative 1, 0, negative 1, and then negative 2. Then we solve it. So these are the value for our I1, I2, and I3. So here we're gonna check our answers by simulating our circuit using multi-sim. Here we're gonna simulate it. So here is our I1, which is 1.4 amperes. And here is our I2, which is 2.4 amperes. And finally, here is our I3, which is 3.4 amperes. So that's it. I hope you have learned how to use Supermesh analysis and solving circuit problems. So this has been MJ, and I'm out.